Okay, we're going to talk about some typical goals for a new electrical design tool, what people are trying to do when they look at this type of change. Today's focus is PLC design, so we'll talk a little bit about that. Quick slide on Javelin and some customer presentations, so just so you know what other people are doing out there with E3.WireWorks. So this is the webinar series that we've run so far. For the half of you that haven't really attended these previously, I thought I'd just bring you up to speed. Our first one focused on schematics design, then we broadened it out to schematics and panel. Then we focused in on the cabling aspects of E3.WireWorks, as well as the SolidWorks integration that can come along with it. For those who are interested and who may have missed webinar number 3, we did set up to record that, and it's available. The full presentation is available via our website. So you can go there and watch that. If you've got any trouble finding it, just give us a shout and we'll be happy to make sure that the link's available. Today's webinar is PLC design. As you all know, software comes out with new releases roughly every year or so, and E3.WireWorks is no different. So tentatively, depending on release dates, we believe that E3.WireWorks 2010 is going to be released in the next week or so. So our next webinar will probably take place in the next 4 to 6 weeks. We're thinking that a what's new presentation may be our next topic. So for those of you who've been following along, stay tuned. There's some really great things that we've already seen in 2010. I think you'll be impressed. Some typical goals that companies are trying to achieve, or maybe some roadblocks that they're trying to overcome when they look at a new electrical tool. Perhaps you're using AutoCAD or something like that along the way. We've got yet another poll that we'll do in a minute, but really what we're finding, and I think what all of you know, is the electrical design process is really labor intensive. You're changing the same information in multiple spots, and if you're using something like AutoCAD or another 2D tool or potentially Microsoft Word in some cases to pull these designs together, you just got to really be on the ball to make sure that you're keeping all that information pulled together. So a lot of energy has just gone into managing bills of materials, wire lists, and revisions. Getting an accurate bill of material can be a struggle on some days, and perhaps the electrical documentation isn't detailed enough, or some things are being missed along the way. So I'm sure you've read through some of those things. Hopefully you identify with some of them. The one we're going to address today is PLC addressing, and that's certainly something that's time-consuming and difficult to keep track of as well. Just certain things related to PLC design that Eric's going to walk us through today are keeping the designations up to date between the schematic and the panel, pin names controlled by device properties, easy addressing, checking for address duplicates, naming the wiring after PLC addresses, and a couple of other good things along the way as well. So hopefully some of these things are areas of interest for folks on our call today. Why choose Javelin as a partner on electrical design? We have a proven track record of identifying and developing solutions for Canadian manufacturers. Certainly, I think everyone knows us from a SolidWorks standpoint and some of the other solutions that we've rounded out. But not only have we identified these solutions and brought them to market, we're actually out there helping people implement them the way they should be implemented so that people are achieving their goals and getting their designs done faster with less stress on time. We do have a strong foundation. We have a good number of people at Javelin. It's 45 plus employees, and we're growing again. I think that number's kind of bumped up a little bit. So for folks who are keeping an eye on the market out there, we're seeing things kind of looking up. We are a complete solution, so one of the things that we're here to talk about today is E3.WireWorks, but I think that there's some synergies there. If your mechanical software is provided by the same company as your electrical software, getting these things to work together and getting those teams of people to work together is something that's just easier to do. Some of our customers, from a SolidWorks standpoint and an E3 standpoint, some of our E3 customers are on here as well. L3 Communications is up there, Michelin's up there, 4C is up there, and a few others. Let's talk a little bit about E3.WireWorks. E3.WireWorks, it's multiple views on one project file, so it's very easy to organize. It's fully associative, so if you make a change to the schematic, the form board will update. SolidWorks can update. If you make a change in the panel, your schematic will update, your bills of materials will update, etc. So really, Changes made anywhere will update everywhere. And this is where you can really start to save some time and just quit pulling your hair out and having to remember where to make all the changes you need to do to keep your designs pulled together. So it's about full associativity and just taking the burden of managing that off of a designer. This is a quick look at the integration of SolidWorks and E3.WireWorks. On the bottom, that gray band represents E3.WireWorks. A little SolidWorks guy in the middle represents the mechanical department, and then Enterprise PDM is across the top. So we really have something that works together. So both SolidWorks and E3 can check into the Enterprise vault, and Enterprise EPDM will manage the bills of materials and make sure that those bills of materials are in sync. We can also send cable information over to SolidWorks, which helps with the routing aspects and making sure that all of the components that need to be placed in the mechanical assembly that are on the electrical bill of material are actually there. When you're running SolidWorks and E3.WireWorks on the same computer, and a point of interest, you do not need SolidWorks to run E3.WireWorks. It can run completely independently of SolidWorks. But if you do want to run both of these on the same computer, then you can cross highlight. So you can right click on a motor in SolidWorks and say show me the schematic. You can right click on the schematic and say show me the motor in SolidWorks, and really kind of jump back and forth between these two. Depending on where you want to do your routing, if you want to manufacture cables directly from SolidWorks or from E3.WireWorks, you can create form boards in SolidWorks, or you can create it in WireWorks, and SolidWorks will pass back length information. A quick look at just an overview of this thing, just jumping, well, let's just stay here and I'll kind of keep moving along here today. A quick overview look at this, and I'll try and get my mouse pointer showing up on the screen. Currently, many of you are probably running SolidWorks, and perhaps you're integrating with a data management tool that is pushing information out to other people in the organization. What we can also start to do is bring E3.WireWorks and PDM into that same vault, making the electrical design and the mechanical designs available to everyone in the organization, and hand both of those things off through automation to perhaps an ERP system or over to suppliers as well. So it's about a flow of information. Some of Zukin's customers, and these are their global customers, so some of these aren't Javelin customers, but I really wanted to just give you an idea of some of the places that E3 is being used out there in the world today, whether it's in the energy industry, the packaging industry, the vehicles industries. And I think we'll dig a little bit into these in a minute. So I've got a number of slides. I'll just sort of go through them quickly, and I'll make sure that they update on your screen. So Liebherr is using this, is using E3. They're a company that do multiple things, as you can see by the picture. So hopefully you're seeing something out there that is interesting. It could be large machines or large industrial machines, large plants or cranes, or even just small electronic pieces of equipment. It's in use in machine design, so you've got some schematics on the left side, and then you've got a little panel layout on the right side there. Plant engineering, packaging machines, automation elevators, escalators, another good use. Also in use in the energy industry, so as you sort of take it up a level, it could be used by Siemens or maybe Areva for nuclear design. We're into electronic systems, so if you're looking at the overviews of these electronic systems with black boxes, this is a good way to put things together. Some of the companies that are doing that, their logos are up on the screen, Miele, Tyco. Also in use in the automotive industry, so if you've got high-level systems you might be pulling together, and you need to sort of document those at the highest level, you can do that. Some of the automotive manufacturers out there using E3.WireWorks, BMW, AMG. At the supplier level, just some extra logos there. Michelin we mentioned already, Continental, Delphi. Heavy equipment, so large vehicles is another great spot for E3.WireWorks. We're into the aerospace industry, so there might be different standards that you need to conform to if you're in military design or the aerospace industry. Those are available in E3. And just a couple of more quick ones, railed vehicles. Just letting this update look Looks like the internet connection might be lagging a little bit. Just wanted to get these pictures going through. Important to note, all of our solutions are not just electrical solutions. They also come with hydraulics and pneumatics capability. And in addition, actually, you can do a lot of P&ID stuff as well. So you don't have to buy a separate package for that.
I think it's pretty clear from those slides how broad of industry spectrum that E3 really is used in. So it really is used everywhere.
Let's just do a quick poll before we flip things over to Eric. Let's just make sure everybody's paying attention here. Currently we are using.
So with that, why don't we get going with this the demonstration portion of the webinar today. I thought I'd start out just by giving just a brief overview of E3 in general for anybody who's new to the design. So what we're looking at here is a cooling water pump electrical project, and we can just move over to some of the schematic portion of that. One of my favorite things with E3 is how quick it is to navigate around. So here we can just take a device and just jump to that device in the panel directly. So you can see that as the device in the panel. Take another device, jump to that one in the schematic to see which one's which. You can also, a lot of the components, they'll come with these references. So you can see that these are references for where that's used. Those joints are used in the panel layout or the schematic layout, so you can see where they are, or again back to the panel. If there's anything in the panel you're curious where it is in your schematic, you can just click on that again and jump to it as well. So it's very easy to navigate around between the different designs. References as well, same thing. You just jump to schematic and you pick up exactly where that reference goes. So navigation is always very easy, and all those references automatically stay up to date. And that's the big power of working off the database. One thing that's also worth mentioning is the way I'm jumping around between these different sheets. Anybody can do that on the project for free, because there's a free viewer with this package that allows you to do exactly that. What we'll take a look at with this design, though, is we'll make a quick modification and just see how that updates on the panel and on the schematic at the same time. So here we're dealing with the panel, and then what I'll do is I'll just navigate out on the schematic, and I'll go and add one of the open, closed, or one of the switches for this contactor relay. So I'll jump to the device tree, and you can see that this device has a few different schematic symbols. The blue ones with their page number next to them are referencing exactly where they are, and the blue ones mean that they're used. And these yellow ones are not consumed yet. So if I wanted to go and put that schematic symbol into my design, it's just a matter of dragging and dropping. Oh, let's just drag onto a spot where I can drop it down here. So it's just a matter of dragging and dropping that not used schematic symbol, and we'll notice that that turns from yellow to blue. And of course shows that sheet reference as well. The nice thing about this associativity is that we'll see that it's automatically represented in the panel. So we'll see that dotted line from the point in Q3, that contactor relay, down to Q5. And if I were to delete that, not only will that line fill in, but the dotted line between those connections will fill in as well, or disappear in that case. So you can see some associativity already happening between the panel and the schematic layout. The other really nice thing is just taking all of those red dotted lines that are all the logic and connection between those devices, and you can very easily convert those to cables or wires as well. So you just do auto connect on any device or numerous devices at a time, and it changes all those to wiring, automatically follows through the ducts and keeps track of any fill rates. It makes sure that low voltage and high voltage lines aren't crossed, because you can designate on the ducts what type of signal or voltage they should handle. So it's very clear to work within that project. Let's move over. I thought I'd just start with that as a brief introduction to E3 in general. And then what I thought I'd do is go over to a brand new project, and what we'll do is just do a little bit of PLC design as well. This is a very similar project to what I used on the previous webinar for some sample overview. So I do have some wiring already done with some circuit breakers and contactor relays and all that other great stuff. And here I'm on a double column sheet. I find that that's quite common with any of the clients that we have that are doing PLC design to design with these double columns. And it is worth noting that E3.WireWorks does keep track of the page numbers and row numbers on the double sheet. So we have the hundreds over there for page 1, and then it continues up on row 41 on that second column. When you drag in a device or a PLC device, we'll notice that it's going to automatically show up as its default schematic symbol. But like I showed you before, if I jump to the device tree, we'll notice that there is actually more information that's associated with that device. So here we'll have, this is a sample 64-bit PLC, and we'll notice that we actually have 4 schematic symbols to break up the 64 pins into different blocks so that you can spread it out on different columns. So from there I can drag over any other schematic symbols onto those other sheets and columns, and E3 will automatically keep track of that. If I were to put that onto a panel, so let's go and create a new panel sheet design, and we'll drag in a new panel. So we'll do just a sample panel here. And what we'll notice is if we drag in that exact same PLC side, it of course shows up as its PLC symbol, or obviously its panel layout symbol. So you can see it in 2D mode. It actually does have depth as well if that's important, but it's quite comfortable just to work in 3D mode. You can also drag components directly into the panel itself. So if you wanted to have numerous PLCs, you can drag them directly in from your library, and they'll stack up in your design. So now I have 2 PLCs. We have one that has none of its schematic symbols used but is located in the panel, and we have one with those 2 blue schematic symbols already used. So it's very easy to keep track of in that sense as well. Let's use this and we'll jump back over to the schematic symbol. Okay. What we'll also do is typically we want to go out to terminals so we can wire up into whatever machinery we're designing. So sub-circuits are a common thing to use if you're doing a bunch of layout work for numerous things at once. In this case, I can drag out an entire strip of terminals, and you can see them added all 1 through 16 in this case. And very easy to just do a quick box select and wire that all up with my PLC schematic symbol there. So very easy to do. If we look at the schematic symbol closely, we'll notice that we do have pin names associated with the schematic symbol. And these pin names, 1B20, 1B19, those are all coming from the device properties itself. So you can use the same schematic symbol and you can switch between devices, and the pin names will automatically update. And that's typically fixed for these devices. What's not, of course, fixed is the addressing. So the addressing we are flexible on, and I'll go over that in a quick minute, but here are the addresses X00, X01 for this particular PLC. One way that's really nice to work with the addressing and all of the information on that PLC is to work with this PLC spreadsheet that you can embed inside of any project that you're working on the PLC front. And what that will do is embed that Excel spreadsheet and work bi-directional with the information in your design. So what I can do is pull in all of the addressing information into this spreadsheet, and I can do a quick test. Are any of those devices addresses reused in more than one instance? And in this case, we'll notice that X00 is actually used in row 4, 68, and 132. So it's actually used 3 different times. And that's not really what we're after today. We want to make sure that we're only used, it's 1-to-1 ratio on that addressing. So we have a couple options with how we go about doing that. We can actually change the addressing in Excel and drive it back. But I did want to point out some of the work that we can do directly in the addressing within E3.WireWorks. First of all, I did notice that I actually had an extra device that I must have dragged in before. So if anything is not needed, you can of course delete that. So now we're down to 2. And what I'll do is on the panel, sometimes it's nice to keep oriented with the addressing when you're on the panel itself. So with these 2 devices, I can click this first one and very easily control all of the PLC addressing in a single field. So here we have, I'm going to say this is device A, and what this coding is next to it is automatically addressing hexadecimal. So this is the X for hexadecimal, but you can use D for decimal or whichever else. And that will automatically address everything within that device. Same thing for this guy. Go to the PLC addressing, change whatever prefix that you want for that device. So we're just changing a couple different fields, and both those devices now, if I browse back to the schematic, we'll notice that all of the addressing is changed with hexadecimal with that prefix A. Okay. What we'll also notice is if I were to go with that spreadsheet again, if I pull in that exact same information and do a test, we'll notice that there's no duplicate addresses now. So that's great. I don't have to worry about addressing when I go down to the programming side and anything being out of sync. One of my favorite things about working with this spreadsheet is driving information within there. So what we have the capability of doing is grabbing some of the text that you've used somewhere else, or really any way that you like. You can just type it in, of course, but you can just fill in the cells like you would any other Excel spreadsheet, and we have the capability of driving that all back directly into our design. When we go and check out our design, we'll notice that all of the notations are going to be updated next to your schematic symbols. So this Excel spreadsheet is a really nice centralized way to control all of the information on your PLC schematic symbols, and of course keeps it all centralized for communicating on the programming end afterwards as well. Maybe I'll just finish off the spreadsheet showing that part, is that there is actually quite a bit of more information here as well, like what are we connected to, where is it placed, and all that other great stuff. But a really nice check is one button away to get that out into comma separated or tab separated text file that can be imported into any programming. And we have some flexibility with the formatting of this, of course, so we will of course make sure that it works for you on any of the programming that you do. Going back to the schematic end of things, I think it is worth noting that the wire names can be updated with the PLC address as well. So it's just a click away to go and update all of the wire names. Oh, in this case I used the wrong scheme. Hold on. We'll just clear all those. Let's rename those. So we'll use the wire numbering, and we'll base the wire numbering based on the PLC address. So what that does is, of course, name those wires. When you're dealing with wire from to list, it'll be A00, and you can see which terminal it goes to and all that other great stuff. So that keeps that up to sync. With those being wired up to the terminal, what we'll also notice is in the panel end of things, it's very easy to go and place and see the associativity between or connection between those devices. So within E3.WireWorks, there's two main tabs that we have for working with the panel. We have a list of anything that's placed. In this case, we have these devices that are placed in the panel. And we also have a list of anything which still needs to be placed. So in this case, what we can do is take all of my terminals here, take all of this strip, just select all of them here, and you can drag and drop them in. And what we'll notice is that there's a clear connection between that PLC and this entire terminal strip. You might have other devices, because I did have another sheet there, and it's very easy just to go and drag and drop those on. And what we'll notice is that we are keeping track of where these devices can be placed. So if we have some circuit breakers there, it keeps track of where they can be placed on the rails. So there's the purple rails that can be placed on. If we do have other devices that I've just populated with, you can just drag and drop those on. And here's another row of terminals. So you can see how those are all wired up together. Any of those devices, let's just take a couple as a sample just to reiterate. If I take all of those devices and right click, we can auto connect those and go between the route, or go between those the rails and ducting for that wiring. Okay? And of course, those dotted lines, we can auto-connect that, or what we can do is we might make a decision to work more on the cabling front, depending on what type of PLC device that is. Doing a little bit more wiring on the schematic end, I thought I'd just point out a little bit more here. So in this case, let's take this PLC input device and wire up with some sensors. So very easy to go and take one of your sensors and drag and drop it in. So here we have a proximity switch. And what I did want to point out as well is very easy just to use regular Windows functionality. You can do your copy and paste and get a whole series of devices in. You can copy and paste an entire block of devices, or copy and paste, of course, the block afterwards. So here we have very quickly, with a couple of copy and pastes, all of these devices are laid in line and are automatically lined up with those pins. We'll want to do a little bit of wiring as well. So we can just use a regular connection list where we do a connector just going straight down there. Maybe we have a connection going down to wire up one of these bottom areas. And then with a simple box select, we can do the remaining wiring. So very quick to do some of the wiring. And you don't have to worry about doing all these lines individually, because we are dealing with some true wiring and real connection. What we also want to do is do some device renaming. So here we have some proximity sensors, and really my goal is to have those named after where they're located. So I should name them on sheet 1, row 8 for that top one, and so forth. Very easy to do all of your device renaming with bulk for an entire sheet. So in this case, I renamed them all with underscore 108. 109. So sheet 1, row 8, row 9. So it's very easy to keep track of any devices that you have in line on your design, and you never have to worry about that naming side of it. And then we'll also point out some sheet referencing as well. So it is quite common to have, if you do have a line over here, what we might want to do is reference from here to make sure that it's very easy to jump. The way that we can do that is with our sheet referencing techniques. So you can very easily just take a sheet reference, whether it's incoming or outgoing. So we'll do an outgoing one down here, an incoming one up here, and then what we can do is on that device, just hit that reference, and you can control very easily what it's referenced to. So we just select that other signal. There we go. And then you can see that it's automatically kept up to date, and we can jump around. So this device goes from that area to the schematic, or this goes to this area in the schematic. So very easy to jump around. And then of course continue some of the design there. So with that, hopefully I didn't miss it front. So going back to the design side of E3, the first thing I did want to point out is how easy it is to take a device that is similar to one that you have before, and we can very easily click on it and do new component. And what that'll do is bring up the library editor, and we can copy it to make a new PLC device. So we'll just do PLC sample, something like that. And you can copy the attributes or say which supplier or the description, so very easy to go and enter that. And you can copy the same structure the way it's set up. What we'll notice here is that we have all of our schematic symbols that we just saw linked to the block that we have there. In this case, it's 4 schematic symbols with the block. And it's very easy to go and take that and switch it out for something else. So in this case, I had a sample PLC block with a different width, and that image I just took from working from the Siemens website. And then of course you can attach your width and everything else to it. If there is information that you want to switch on your schematic symbols, like maybe this one's whatever device it is, maybe it's only a 32 pin PLC, what I would end up doing is likely switch out the middle 2 symbols or schematic symbols or anything else. Maybe there's other connections that are required. I can drag those symbols in. So out of your symbol library, you can drag and associate them, name them, and then you can save it to your library. And then instantly that's
integration if you're using those products. It's important to note, again, I already did it once, but I'll say it again, E3.WireWorks will run on its own. It doesn't require a license of SolidWorks to use for electrical design, but there is some advantages to using both licenses together. And then I think from what Eric showed today, it's a fantastic tool for automating some PLC design and keeping that sort of pulled together. So I just wanted to wrap up on that. That's everything that we have. I think that we'll probably close down the phone lines, and we'll continue to answer questions online as best we can. We'll close out all the questions, even if we don't have an exact answer for you today. We'll let you know, hey, we'll get back to you, and we'll give you a call later through this week.
Yep, and if there's I can still show a little bit on my screen as well if there's any questions that are worth answering by demonstration. So sit tight for a minute, and then I'll see what we can do in that